So people listening to in YouTube, I would like to wait for 5 more minutes until some more people join. Currently, there are not many people listening, so we'll wait for a few more minutes. Then we'll start. Can someone please comment in YouTube if you are able to hear me and see me? Are you able to hear me? Okay. Thanks, Hue. Okay, so let's wait 2 more minutes. It's 7:03. We'll start the class at 7:05. Okay. So Sahil and Shipra, did you guys get laddus? Yesterday, I asked the CodeChef people to deliver the laddus. No, you did not get them? Please check your mail once. So I asked the CodeChef people and he told me that they were successfully sent. Like, do you know where to check them? Like, is it CodeChef? Can you check your mail? Because you should have gotten them. Okay. What was your username, Sahil? What was your username, Sahil? Oh, you got it? Oh, nice. Cool. Today you are going to get more. Shipra, please confirm you as well. Oh, nice. Cool. More laddus to win today. Luckily, there aren't many people today, so you might win more. Okay, so yeah, let's start today's class. It's 7:05. No, Krishna, we haven't started the class. We are just starting the class. We were waiting for more people to join. That's fine. Like, there are 3 people right now, and it's better if it's less people as well. You guys will have more time to ask me doubts or anything. Like, we can discuss more things at the end if you guys have anything to talk as well. Some of you, if you don't know me, my name is Surya Kiran. I was ICPC World finalist twice, like the guy on the left here and the guy in the middle here. I was also Red and CodeChef for a while when I was active in 2014 and 15. That was probably the peak of my career then. Now I'm a little old in this community. I worked in Google London for 1 year, 3 months, and Google Mountain View for 3 years. And last January, I quit my job to work on my own startup. So that's my work experience, and I did my bachelor's from IIT Roorkee. I did bachelor's in electronics and communication engineering. So I was that. Uh, my teaching experience, I taught many weekly lectures to my juniors in college, and I attended some programming camps and taught there as well. I also taught around 6 to 7 classes in an academy so far. So those of you who don't know about this yet, like from tomorrow, there is a course starting in an academy. It's called Everest, and basically it's a complete course for beginners to become to expert level. If you already know it, like if you are already good at programming, then also it will be beneficial for you. The reason is like a lot of people waste their time into finding new resources to learn competitive programming, but this is a structured learning. Like you don't have to search for anything. Everything will be already put in place for you. So the instructors are like really highly competent. They were like ICPC World finalists, IOI medalists, and like a lot of experience in teaching there. Uh, they will help you like get placed in FANG companies. Like the things that you learn here, mostly they'll be useful for cracking interviews and also improve your problem solving skills. Uh, it will also help you cracking international coding contests as well. Uh, so upon the completion, you will also get CodeChef certification, uh, which will be very useful to put it in your resume. And the expenditure will be like around $90 a day. It's not very much. It's like very cheap. Like so, I think it is a great deal for you guys. Uh, those of you who want to learn more, it's better if you do it. So what are we doing? We were like, this is a like micro course of 4 classes. uh, till now we did 3 classes before, and today is the fourth class. Today we are going to solve some competitive programming problems and apply our knowledge that we gained in the previous 3 classes to solve actual problems. So no theory today, it's purely problem solving and improving our understanding more. So these 7 people uh, have entered their CodeChef IDs incorrectly. I don't know who you guys are. In the last 2 classes, you guys entered these CodeChef IDs. So all of these are incorrect. So if you guys are one of these, then please uh, enter an updated CodeChef ID. Uh, if you or one of your friends is in this list, then uh, please ask them to fill this form and send an updated ID. We will try to get your laddus delivered. Okay, so you guys have 1 laddu, so uh, please don't try to waste them. They're precious. So yeah. So again, who's ready for another game, right? Like we played some games last classes, right? So this time today you're going to there's a chance of winning more than 1500 laddus. So less people, less competition. So who's gonna win these laddus? Let's see. So game one, I'll paste the link. 1 second. So I'm pinning the link as well. Open this link and select one of the answers, and then and also read the details. If more than 2 persons pick 500 laddus, it's not 50%, it's 2 persons. If more than 2 people pick 500 laddus, then no one gets any laddu. Else you get what you pick. So within the next 5 minutes, try to pick the right choice. Uh, So okay. Shipra and Sahil, have you gotten a chance to open that link? Because I don't see your guys' responses here yet. Okay. If more than 2 people pick 500 laddus, then no one gets any laddus. Okay. Sahil, are you there? Are you able to open the link? Okay. You haven't selected your answer yet. That's why I was asking. Okay. Looks like okay. So we will end this at 7. When did we start this? 7:15, 7:05. Sorry, 7:13. Let's wait for 3 more minutes. Okay. 7:12. We started at 7:12. So yeah, the game will end 7:17. Okay. Actually, it doesn't matter. Like 3 people selected 500, so it doesn't matter if we wait for more time. So sorry guys, you are not going to get any laddus. All of the 3 people who are attending this class have selected 500. So yeah. So what did you learn? Like being greedy doesn't always help, right? Like so let's move on to second game. Okay, this time it's being to be more complex. Like it's either 1000 or 0. So select one of the 2 options. I am again pasting the link and pinning it on the top. Stop accepting responses. Yeah, I'm like select in the next 5 minutes. Let's do this not 5 minutes. Let's do it only 3 minutes. Within the next 3 minutes, it's 7:17 now. Up to 7:20. Please try to fill up this form. If more than one person selects 1000, no one gets anything. Okay. Okay. I think it again doesn't matter again. Uh, Three people have selected 1,000. You guys are being so greedy. Like no one is going to get anything. Uh, every like three people selected 1,000. So yeah, let's stop this game again. The limit was only two people, one person selecting here. Yep. So how was this? Like being greedy. Like you guys should have learned your lesson in the first game. You did not. So does anybody wants to share your reasoning? Like why you selected 1,000 and not 10? Because you don't want others to get 1,000, is it? Selected 10 the first time, Keshav. Okay. Okay, so. But this time you guys selected more, right? Like, yeah, this time 100 to 3. No, 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 Sahil. We can't change the game rules after the game finishes, right? There, so there is one more question. Like there is one more game at the end of this class. Okay. There is one more game at the end of this class. So wait for it. It will be different than this. Like it will be different than all the games that we played so far. It will be interesting. Trust me. So there many people can get more than okay. Okay, Shav. Okay, so you selected because you thought other people wouldn't select. Yeah, so maybe others also thought that and they selected. So yeah, bad luck, right? Okay, so we are going to move on to the class, today's class, and see what we got to learn today. I'll just give a quick revision of what we learned so far in the previous classes, like in 5 to 10 minutes, so that people who just joined today will have some good revision. Sorry, good understanding of like they don't feel out of place. So the games which we are going to talk about today are going to be like this on the right and not on the left. So we are going to talk about games which have coins, which have this, like mathematical games. Basically, like you have to select something, your opponent has to select something, something like that. These games are mostly one or two player games. Uh, so there is that, and it is perfect information. It means that everybody knows every information that is to be available, right? The game that we just played before during the start of this class, those are perfect information games. Like nobody has some hidden information, secret information that they know. So these are perfect information games that we are going to discuss today. And there are no chance moves. Like the game that we played today, there is no chance move, right? Like you just select what you want to select, and your opponents select what they want to select. There is no random dice throwing, right? Like I did not say I'll throw a dice, if it's even then I'll give everybody 1,000 ladders. I did not say it like that, right? So similarly the games that we are going to discuss today are no chance moves. So tic-tac-toe counts, yes. Tic-tac-toe is a perfect information game. It is a one or two person game, and there is no chance in tic-tac-toe, right? So yes, tic-tac-toe counts. Win or lose or draw outcome. Every time there is a win or lose or draw outcome, right? Even in tic-tac-toe, there is always a win or lose or draw outcome, right? So going further, we developed this small pseudocode, which means that we assign each position either it is winning or losing, right? So a state is winning if and only if it can go to a losing state. Say we can go to three states here. This position is winning if and only if one of these three states is a losing state, losing position. Like you make a move and you give this position to your opponent. So if your opponent's position is losing, then your position is winning. If none of the positions that you can give to your opponent is losing, then yours is losing. Let me repeat that again. If all the positions that you can go to are winning, then your opponent is winning whatever you do. That means that you are going to lose no matter what you do. So it will be losing position. If one of the position that you can go to is a losing position, then this is a winning position because you can put your opponent into a losing position. How do we calculate whether uh, this is winning or losing? You simply do a depth first search or breadth first search. Like you go to your child states, calculate those, and then we backtrack to the current position. Like you recursively call the moves that you can go to. If one of them is not winning, then this is winning, else this is losing. Okay. um, let's go further. We also learned about a very famous game called nim. It's the most famous mathematical game ever. There are a lot of problems based on this in code forces, CodeChef, Topcoder, everywhere, and it requires very clever ideas and it requires very less amount of code. So if you are good at solving these game theory problems, you will have a really good advantage over your opponents in competitive programming. uh, so there is that. So the statement is very simple. There are n piles of coins and you select, in your turn you select one of the pile and you take away at least one coin up to whole pile. You have to select one of the piles, you have to take at least one coin. You can take the whole pile as well. If there are like 5, 4, 6, 2, 7 coins in each of these piles respectively, you can select this pile and you can take away 3 coins or 4 coins. You can take away 6 coins as well, but you have to take at least one coin. Okay, 1, 2, 3, 4, 5, 6. You can take away any number of coins from this pile. And the solution where we learned in this game was like if the XOR value of all the piles, if it is greater than 0, then it is winning. If it is equal to 0, then it was losing. Why? It is a very nice, clever, intuitive proof. Not non very counterintuitive proof. You can go to the previous classes and see how it is true. Okay. So we also learned about minimax algorithm. So there are two pairs. One tries to minimizes and one tries to maximize. Um, we assign a score to every position. So to the initial position, what is the score of that? This we calculate using backtracking. First we calculate the scores of all the child states, then we calculate this. There are so many use cases for this in chess, Go, a lot of games where we can use this minimax algorithm to solve the problems. Okay. And then Grundy numbers, we have learned about this in the last class. Grundy numbers are basically the minimum excludent of the set of numbers, Grundy numbers of all the positions that you can go to. Okay, so currently, say this is your current position. You can go to new position 1, new position 2, new position 3. So the Grundy numbers of all these three positions, we try to select the minimum excludent of that set. Okay, what is the minimum excludent of this set? Is it option A 3, option B 6? What is the minimum excludent? Select an answer. I will create a poll. What is the minimum excludent? Okay, good. Minimum excludent is 3. One of you selected 6. I it is very simple. The person who selected nothing complex. So the minimum integer which is not present in this set, it is called minimum excludent. Okay, minimum whole number which is not present in the set. So here it is 3. 3 is not present, right? So that's why it is minimum excludent. And what is the minimum excludent of this? Option A 1, option B 6. Okay. Okay, good. Everybody selected. Correct. So you got it. So let's go further. So we also learned about composite games, like combination of multiple simple games. So NIM is a simple game, right? Uh, it is a so NIM is also a composite game actually. Like there are multiple piles, right? There are n piles. Each pile is a different game itself, right? Like if there is a single pile, it is a simple game. But if there are n piles, like the numbers you select from this pile, they will change the outcome of the whole game. Like so, each pile is interacting with all other piles. It's not an independent pile, right? So if there are n simple games, we calculate the Grundy number of all the n different piles, and then we apply XOR over them. Like we treat them like the game of NIM using the Grundy numbers of each simple game. Like in the game of NIM, there are n piles, and each pile has AI coins. In this, there are n simple games. We calculate the Grundy number of each one. Ith pile has GI Grundy number. So in game of NIM, what we do, we apply XOR of AI over all I for all I. Here, the same way we apply XOR over all G and calculate. If it is greater than 0, it is winning. If it is equal to 0, it is losing. Why does this work? The same way that we the pseudocode that we algorithm that we started before, right? Like from every losing position, you can only go to a winning position. From every winning position, you can go to at least one losing position. So that is the reasoning. Yeah, Sprague-Grundy theorem I just explained in the previous slide. If the XOR of all the GI, if it is greater than 0, then it is winning for the first player, else it is losing for the first player. Any questions so far based on the previous 3 classes? Do you guys have any questions? I'll wait for 1 minute if you're typing. If you have any questions, do you want me to repeat anything from this? I will be glad to do that. Okay, Keshav, I'll explain it. So it is very simple. Okay, so you are in this current position, right? You can go to, let's say, three new positions. These are three moves that you can make and go to these three positions. Okay, so basically you write the Grundy numbers for each of these three new positions. Okay, and the minimum excludent of these three numbers will be the Grundy number of this. Okay, if the Grundy number of this position is 2, if this is 3 and this is 0, what will be the Grundy number of this position? 1, right? Exactly, that's simple. So that way you calculate the Grundy number of each position. It is also called number. Just you replace u from number, you will get number. So basically, if you have a complex game like this and you have multiple complex games, like if you have n complex games, sorry, n simple games, you get a complex game. So this is a simple game. uh, Similarly, if you have multiple simple games, if there are n of them, in the game of nim we have like n piles with AI coins in each. If you have n simple games, you calculate Grundy number of each and you just treat it as a game of nim with GI piles in the ith pile, GI coins in the ith pile. Okay, so it is that way. What if the node has no children? What is the MEX of an empty set? What is the smallest integer which is not present in this set? 0. Yes, that's it. Right. So it is that. Let's go to the today's class. Okay. So let's start with first problem. There are n piles of stones. Ith pile has AI coins, and two people play a game where they take alternating turns removing stones. In a turn, a player may remove a positive number of stones from the first non-empty pile. So there are multiple piles, right? N piles. From the like, if these two piles are empty, you pick the third pile, which is non-empty, and you have to remove positive number of stones from this. Like these two have 0, 0. Let's say this has 3. Let's say this has 5, 6, 7, 8, so on. You have to remove at least one coin up to 3 coins. You can remove 1 or 2 or 3. You select the first non-empty pile and you remove positive number of coins. If both players play optimally, determine the winner of the game. You will have like 5 minutes to think on this. This is not 5 minutes, 3 minutes to think on this. Like this is very simple problem. Like it's probably due to B or C, I don't know. So think about it. Like use your understanding that you had from all the previous classes and try to solve it. If you have gotten the solution, write it in the chat. I will read all the solutions that you present, and later after 3 minutes I'll explain the solution myself. Okay, is anyone able to solve this? Keshav, Sahil, Krishna, Shipra, whoever is there. What are you thinking? Same as nim game logic. How Sahil? This is simpler than nim. No, Keshav, your solution is also wrong. Try to think recursively. Calculate number for each pile. What will be the number for each pile? You can number is just the number of coins in each pile, right? You have to remove positive number of coins, so the number will be just same as the number of coins in that pile, right? You have to select the first non-empty pile. In the game of nim, you can select any pile, so it is different than nim. You cannot apply the nim logic here because in nim there are n piles. You can select any non-empty pile, but here you have to select the first non-empty pile, like the leftmost non-empty pile. In nim you can also select this pile and remove any number of coins, but in this game you have to only select this pile. What, Anubhav? Do you have any thoughts on how to solve this? Okay, let's make the like, so I'll give some small hint. Okay, then you guys can think how to solve. What if there is only one pile? Who will win? What if there is only one pile? Who will win? A, first player. B, second player. Right? First player should win if there is only one pile. What if there are two piles? A, first player. B, second player. Who will win? What if there are two piles? Oh, nice. Nice, Krishna, you got it. What if the first pile has one coin and the second pile, and there are two piles? Who will win? First pile has only one coin and the second pile has any number of coins. Who will win? Okay, if there is more than one coin, so if there is more than one coin and two piles, who will win? There is a poll. Select your answer there. Okay, good. So nice. Everybody selected the correct answer. So what if there are three piles and the first one has one coin? Who will win? First player or second player? Oh, no, 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 no. So it depends, right? If there are three piles and the first pile has only one coin, who will win will depend upon the second pile, right? Right, Krishna. If the first one has one coin, it will depend on the second pile if the first player is winning or not. If these two piles, if the second player is winning, then the first player will win if there are three piles. If these two piles, if the first player is winning, then the second player will win if there are three piles, right? Let me erase this all. If there are three piles, if there is only one coin, the answer will depend on the rightmost pile, second pile, right? There are two cases. We are at third pile. Second pile, first pile. So the answer for third pile will depend from the answer from second pile. The answer for second pile will depend on the answer of first pile, right? If there is more than one coin, then definitely first player will win from that pile to the end. Like if you are just considering n, if there are n piles, if you are considering the last k piles, you store the answer in dp of k. Okay, we maintain an array, we store the answer in dp of k. dp of k will be, let's maintain either 0 or 1. 0 means the second player will win, 1 means the first player will win. This is equal to 1 if a of k is greater than 1. This will be equal to 1 minus dp of k plus 1 if a of k equal to 1, right? If this current pile, what, like if we are like choosing the kth pile, if this has only one coin, then the answer will be the opposite of the k plus 1th pile, right? Is it clear? Is the solution clear? So if there are, okay, great. Looks like you guys understood this good. So let's move on to the next problem. That way we recursively calculate or iteratively calculate from the right end to the left end. Okay. Problem 2. Mehboob and Ehab play a game called even odd game. Ehab chooses his favorite integer n and then take turns, starting from the Mehboob. In each player's turn, he has to choose an integer a and subtract it from n such that a lies from 1 to n. In Mahmood's turn, a has to be even. In Ehab's turn, a has to be odd. If the current player can't choose a number satisfying the condition, he loses. Can you determine the winner if both play optimally? What if n equals to 100? Who will win? A. Mehboob, B. Ehab. Is the question clear? Okay, only Sahil got it correct this time. Others did not even attempt. Is the question clear? Okay, I'll repeat the question. There are two players playing, Mahmood and Ihab. In their turn, they have to select any integer a from 1 to n. In Mahmood's turn, he has to select only even integer. In Ihab's turn, he has to select only odd integer. And if the current player cannot choose any integer a, then he loses. And they have to subtract that a from n. If the initial n was even, the first player is Mahmood, so he can just select a equals to n and remove all the number of coins and he wins. If n was odd, then whatever even number that Mahmood selects, n minus a will be odd. So Ehab will select that number and Ehab will win. So the solution of this problem is simple. If n is even, then Mahmood wins. If n is odd, then Ehab wins. Let's go to third problem. Alice and Bob play a game. I would suggest you guys to read it. Okay, I'll explain this. There are n plus 1 cells. Currently you are in the nth cell. You have to go to left. You can only go left. Okay, this is n, this is 0. Okay, 0, 1, 2, 3, so on up to n. In each turn, you can either go to n minus 1 or n minus 2 or n minus k. Okay, this is n minus 2, this is n minus 1. In each turn, you can only go to n minus 1 or n minus 2 or n minus k, where n is your current position. Like if you are at I, you can only go to I minus 1 or I minus 2 or I minus k. Okay, is the question clear? The person who can't make a move loses. So the solution of this problem is as follows. If k is divisible by 3, then if n was divisible by 3, then second player wins. If it's not equals to 0, then first player wins. The reason is actually not true. Okay, if k is not divisible by 3, then if n mod 3 is equal to 0, then second player wins, else first player wins. Why is this true? you are removing either one coin or two coins or k coins. Okay, initially, if let's look at n mod 3, if it was greater than 0, you can select n mod 3 number of coins and make it to 0. Like your winning position will be n mod 3 greater than 0. You can move to a position where n mod 3 equal to 0, right? You can always move to this position. If n mod 3 was 1, you pick away 1 coin. If n mod 3 was 2, you pick away 2 coins. You can always move to a losing position from a winning position. If n mod 3 was equal to 0, if you pick 1 coin or 2 coins or k coins, any number of coins, you will always go to n mod 3 greater than 0. Okay. This was our pseudocode that we learned before. If you guys did not understand, please go back. I wanted to discuss 2 more problems, but before that I want to play a game. So I would give a game. Select an integer between 1 and 100 or 0 and 100. 1 and 100. The person who is closest to the average into 2 by 3 will get 100 laddus. If there is more than one person with the correct answer, all of them will get 100 laddus. Okay, those people in the next 5 minutes, those people who are watching this class, open that link. The first 50 responses in the next 5 minutes are going to be considered. Game is simple. Select an integer from 1 to 100. Those people who just joined, just select the link that is there in the chat. Open the link and enter an integer from 1 to 100. The person who is closest to int of average of 2 by 3 will get 100 laddus. If there is more than one person who is closest, all of them will get 100 laddus. So okay, whoever is there in the class, like those of you who are watching on YouTube as well. Okay, somebody is just asking in the YouTube. Just pasted the link. Open that and enter an integer from 1 to 100. The person who is closest to 2 by 3 of average will be getting 100 laddus. There is more than one person, everybody will be getting, everybody who is closest will be getting 100 laddus. Okay. Do you guys like this game? What are your thoughts when you're submitting this? Sahil, are you there? Why did you select the answer? Oh, nice. Krishna, you are right. Krishna, you are right. Yes, Krishna, there is no point in selecting number greater than 66. Okay, we are going to end this game within next 1 minute. At 7:59, we are going to end it. Wow, we got 9 responses. In the previous 2 games, we only got 4 or 5 responses. Here we got 9 responses. Wow. We're gonna end this contest game in 1 minute. When it reaches 8 o'clock, we're going to. I'll stop accepting responses and I'll announce the winners. Kartikeya, I just pasted in the chat. I am pasting it again. I don't know why you are not able to see. The link is also present in the. You can see it in the slide. So after we submit this, after we end this game, let's think logically. Like if there are n rational people, what should they select? So that everybody gets laddu. Think about it. If there are n completely like highly intelligent people, fully rational people, what will they select? Okay, I'm going to stop accepting responses in this chat. Okay, so we have 11 responses. I'm gonna calculate the average. The average was 47. So 47 into 2 divided by 3. It is 31. 31. 31. Who selected the closest? Somebody selected 29. He's too close, like 2 distance close. And some people selected 33. They also got it. Wow. 1, 2, 3, 4. 4 people selected right answer. Either 29 or 33. So the average was 31. So those of you who selected 29 or 33, you are going to get 100 laddus each. Congratulations. I hope you guys selected the right answer. Yes, Sahil, you also won. You selected 33, right? Nice. And Mercurist. Who is Mercurist? He also won. Coder Guy and Krishna 1223. He also won. Oh, Krishna, you are Mercurist. I thought you are Krishna 1223. Okay. So what if there are fully rational people? What will they select? As somebody already pointed, you are selecting 1 to 100, right? So if people are selecting randomly, I don't know why that cursor is there. If there is 1 to 100, if people are selecting randomly, the average cannot be more than 67. The average cannot be more than 67. Why? Because if all people selected 100, then the average is highest. the 2/3 of that average is cannot be greater than 67. So all those rational people will only select from 1 to 67. Uh, so all the rational people will select from 1 to 67. So if everybody randomly selected from 1 to 67, what is the maximum average that can be? It is 67. The average can be maximum 67. The 2/3 of it will be somewhere around 45. So no rational person will select more than 45. So if no rational person selects more than 45, what is the maximum average it can be? 45. The 2/3 of that will be around 30 or something. So no person will be selecting more than 30. So recursively, if there are n highly rational people, then everybody of them will select one and everybody will win. So if some of you guys have selected one, I would have been really happy, like to see that. But still, you guys have thought about a good logic that other people might not be intelligent, so they will be averaging around 50. So you guys selected 33. So nice, nice logic. So yeah, congrats guys, those of you who have won. Your laddus will be sent by tomorrow or day after tomorrow. Shubham, yes, they'll really be provided. In the last class and previous class, for the people who have won, they already got the laddus. So if you have participated in this and you selected either 29 or 33, you are going to get 100 laddus. I don't know your username. Yeah, so before we wrap up, so there is something called, I just want to give a, just tell about this again. So there is something called Everest program that is going to start tomorrow. So if you guys want to learn more about competitive programming, please join that. I would strongly recommend that. And there it is. Thanks for joining, guys. That's today's class. We're gonna end this now. Thank you. Bye bye.